Welcome back to First Python Notebook. I am still Ben Welsh, and I am still broadcasting live from Manhattan, USA. Here in this next section, now that we've got our notebook up and running and we've had a basic tour of how it works, we're going to begin to write some actual Python code, including Python code that works with numbers and data and really the rudimentary bits of code that go into doing data analysis. It's a long way from where we're going to end up at the end of this class, but we're going to start small. So I'd like everybody to go back into the notebook that we left off from last time in our introductory modules and open it back up. Here you can see in JupyterLab Desktop is my two cells, my first little headline and the most important piece of data in any journalism document, the byline, and one line of code that simply is 2 plus 2 equals 4. If we hit the play button on that cell, as we learned to do earlier, we can see the results are the same. 2 plus 2 is still 4. We could, just for fun, we could add on a little more math into that cell. If we say 2 plus 2 plus 2, I think you know the result. It's 6. There's all kinds of different math that Python can do. Replace a plus with a minus, and now you have subtraction. You can even do, let's simplify it for fun. You can even do division. 2 divided by 2 with a slash is 1. And 2 star 2 is how you do multiplication. Boom. You've got all the basics of math and Python right there as we just worked through the code. But in each of these cases, you can see that as we wrote our code, it simply just spit the result down into the output. It passed it out and printed it here in our notebook, which was useful. Just like a calculator, it gave us the answer, but it's not reusable, right? So that the result of our little math equation is sort of one and done. It's over. But as you write computer code, you're sort of you typically are doing your task in a series of steps. You can end up having dozens and dozens of little incremental instructions that you give the computer to get from point A to point B, from reading in your spreadsheet to analyzing it and filtering it and sorting it and grouping it and calculating statistics, right? Like you might for a story. You can end up having dozens of little itty bitty cells, one for each of your tasks. And the only way to do that is to take the result of an individual cell and save it to make it reusable in the subsequent cells that follow. And the way that this is done in computer programming is to take the result of whatever operation, whatever computer code you're running, and to stick it in what's known as a variable. And a variable is really just a name that can be reused later on, just the same way a file name is. So for instance, I'm going to type into my cell, and you should too, the name of a new variable, which I'm just going to call number. I'm very creative, as you can tell. And number, space, and then the equal sign. This is known as the assignment operator, equals. And then anything that comes to the right of that equal sign, anything at all, as long as it's legible Python code, will be saved into the variable known as number, right? So if I type 2 plus 2 after the equal variable, and I hit plus, you can see that the cell has run, right? And nothing went wrong, but nothing has been printed out because the result of operation 2 plus 2 is now, instead of being printed, it's saved into this variable. So now if in the next cell, I type the name of my variable and I hit play, number, play, boom, the result is now printed out into the subsequent cell. Just to prove the point, number doesn't have to be named number. It could be named anything. It could be named Ben, right? So if I do Ben equals 2 plus 2, and then I type Ben and hit enter, it's also 4, right? And so variables are pretty flexible. You can call them whatever you want. The only rules are they can't have spaces in their name. So if you want to have a space, you want to say, call it my number, you need to put an underscore where the space was, because this would not work, but this would, right? You can also use uppercase letters if you prefer. It's just in the world of Python, it's seen as good form to stay lowercase. But that's really just a convention, like so many things in computer programming, not a law. And so I'm going to go back to naming my number. And I'm going to try to make my code a little more sophisticated. I'm going to add another math thing on there and hit play. Oh, what happened here? Ah, we have our first error. So you can see that I meant to type 2 plus 2 plus 2, but I forgot the 2, right? I left it off. And so when I hit play, I got this red box screaming at me, and this is our first computer programming error. Computer code is very strict. Computers are incredibly literal. And if there's any small typo or any sort of mistake in how you put together your code, is going to cause an error or freak out in the notebook. Now, one thing that's nice about Jupyter is it kind of formats that for you a little bit to give you some more information. And even though this can be kind of frustrating when you're a beginner, because you may not know what you've done wrong, the most important thing is just to kind of chill out and carefully read the message and see what it's trying to tell you. Now, in Python, the key thing to know is that when you're reading an error message, to understand what happened, you should almost always start at the bottom and read up, which doesn't come naturally, but you'll get in the habit after a while. And you can see here at the bottom, it's actually telling us what the error is. It's saying invalid syntax. You've written something I can't read, right? And then helpfully above that, it even points to the line of code, and the little caret tells us here is where I struggled to read the code. And it's just saying, hey, you put a plus sign in, but you didn't say plus what, right? And so that caused this mistake. So if I strictly put that number 2 there at the end, now hit play again, we're back in business, right? No error, it's been saved. If I type number in my next cell and hit play again, boom, it's now printing, just like before. All right, so let's let everybody a chance to get to where they have a variable saved and some sort of math operation going in there. Next, to reuse this in another cell, you can take your variable and you can put it in an equation like any other. So just as we did 2 plus 2 plus 2 here, down below I can do number plus 2, hit play. That will, of course, return 8, right? Because it's 2 plus 2 plus 2 plus 2. If I change that to a star for multiplication, that'll be 6 times 2, and boom, we've got 12. And it's this basic sort of structure of writing a piece of Python code, saving the result to a variable, right? And then reusing that variable with more Python code as you work down the notebook. That is the pattern of almost all Jupyter notebooks, right? It's just the code that you see ends up being quite a bit more sophisticated. But the general idea, the general approach is the same. Now, there's other Python things besides multiplication, of course, and numbers. There are a couple other types of variables that can be saved into Python that's important to know. One is characters of text, which are often just called strings, right? So when you think about it, a column in a spreadsheet, every column in a spreadsheet is, either a list of numbers or a list of names or words, right? Is a second type. And then a third type is maybe a list of dates. And depending on whether the data are numbers, characters, or dates, the different types of operations the computer can do on the data can vary, right? So in our case, and in this class, and in data journalism, we often focus on numbers, but the other ones have their places as well. And anytime you want to save a piece of text in Python, you have to put it between quotes. And so, for instance, if I do 2 quotes and put my name inside of it, and I'd ask you to do the exact same, Ben, I can now run that code and it will print out my name, right? And that variable could then be saved to name equals Ben. And we've saved it there. We could even get weird now if we want. We could do name times number. And look, it's then taken my name, Ben, and it's printed it 6 times in a row. Not the most useful piece of data journalism, but just to illustrate the point, we have sort of these 2 different data types, right? We have our numbers, which can be saved here, and our name, which has got quotes around it, which is strings, which is saved here. And to Python, it doesn't matter. The variable could be numbers, it could be names, it could be a date, it could be a function, it could be a whole lot of other things, but really anything can be saved into a variable. And that's part of what makes Python a very easy programming language to write. But anytime you're kind of encountering a variable or reusing it, you have to keep in mind what exactly is in this variable and what do I want to do to it? Because if you don't, you might end up with something kind of useless like this, though entertaining. And then a final important data type to round off, our thing is what's known as a list. And a list is really just a collection of more than one things that could be saved into a variable. So for instance, you take two flat brackets, you make a list in Python. Let's just put in there all of the even numbers between 0 and 10. So we do first the number 2, then a comma, a space 4, comma, space 6, comma, space 8. We now have a list of the even numbers between 0 and 10. And if I hit play, that will be printed out, right? I can save that into a variable for reuse. I'm going to call it my_list. You should do the same. Hit it. Just to illustrate the same principles we've learned already, my_list times 2 will then just double the length of the list. Not that useful, but it just goes to show the basic principles again, right? All gone well, I hope. Now, a list, if you think about it, is really the fundamental data structure of a column of numbers that you would have in a spreadsheet or something that you've counted or tracked that you might want to analyze for the story. It's the same as a column in a spreadsheet. And working with lists is really at the heart of data journalism. And even the fundamental Python data types have built in there some statistical methods to help you analyze the data and ask and answer questions. They're very powerful. They're often all you need to write very basic computer code. However, they're pretty limited in what they can do. And they are oftentimes require writing enough code that it becomes a hassle. And so the tools that we'll learn later on, like pandas, which we'll cover in a subsequent chapter, are all about making that type of data analysis easier. However, deep down inside of Python are many fundamental tools for doing really basic data analysis. One is a function called len. If you just type in len, right, you can see it turned green in Jupyter, which is Jupyter signaling, hey, this is like a magic word that's baked into Python that can do stuff. Better not save it as a variable. It's got special powers. If you do len parenthesis, then the name of your list, my_list, close parenthesis, right? And then hit play, you'll see that it prints the number 4, right? And so 4 is the length of the list. There are 4 numbers in the list. Length is a computer programming term for just a count, right? Or the number of observations found in the data population or the data sample. And len is just a little shortcut function that was baked into Python that does a very simple piece of data analysis. We ask the question, how many numbers are in our list? Len returns 4. While we could easily do that with our sort of mind by just counting this very short list, if you had 400,226,113 numbers in the list, which you probably couldn't count just by looking at it yourself, len could provide the answer to the question just as quickly as it did with 4, which is, again, the power of computer programming. Another helpful Python tool that we'll bring out now just to teach you some of the basics, but also to illustrate how much easier this will get later on, is sum, which will take all the items in a list and add up the total. So if I do sum parenthesis, my list, close parenthesis, it will add up those 4 figures together. And we see the answer is 20, right? Which if we do 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. Good job, Python. You got it right. Another built-in bit of statistics that comes with just right out of the box with Python. Now, this parenthesis is a new thing for us. Anytime you have sort of the name of a method or a calculation followed by parenthesis, what it's doing is it's asking for input, right? So if you just, len has to be told what you want the length of, right? It needs an input into the math function so that it's able to provide you with the answer or the output. And the parenthesis is Python's way of sort of allowing the function to receive input. So anytime you see the name of a method or function followed by a parenthesis and then a variable, in a closed parenthesis, that variable is the input to the function. Many functions allow more than one input. It just all depends. We'll get to some more complicated ones later on. Now for our final trick, we're going to use just only the things we've learned thus far to calculate an average. So an average, for those who remember their math class, is really just the sum of a list of values divided by the length of values, right? So to calculate the average value of our list, we just need to divide the sum by the length. So I'm going to copy and paste my sum length, type space. I'm going to hit the slash for divide, the little trick we learned earlier for running division. And then I'm going to copy and paste the length of the list on the other side. And if we run that simple division, we see that our average value is 5 within our list, right? And it added up to 20. There's 4 values. It checks out. And so there you have, in just a very rudimentary way, run a very basic data analysis in Python, right? Maybe having never written any code before in your whole life. It's really not that hard. Just the main principles you have to learn, as we covered before, is how to kind of do math in the Python system, how to save variables, how to group together numbers into a list, and then how to run some basic stats against those lists, right? Now here's where the notebook becomes really handy. So we've written this code, but it's really only for this one list. But because everything here can be easily run and rerun just by clicking a few buttons, you can go back up to your list, and I challenge you to do this, and you can switch it from the even numbers to the odd numbers, 1, 3, 5, 7, 9. I've changed my list to those numbers. Now if I go to the Run menu, and I say Run selected cell and all below, it's going to start from the cell I've selected and rerun everything down the page. Boom. And you see now that, our silly little multiplication comes out different. There's now 5 items in the list, not 4. The sum of the list is 25. And hey, even though we changed the numbers, it came out different, right? Just to prove this with something more drastic, I could put the number 999 at the end of my list and hit the play button a few times to run down the page. And we see that, wow, that average really got a lot higher, right? This here is a great example of an outlier skewing a data analysis. A really common problem we run into with data is a really, really big number that's significantly greater than everything else in the data set can really take an average and blow it way up beyond what might be representative of the overall data set. For those who know their statistics, the common solution to this problem when you have large outliers is to use a median instead of an average. The median, rather than doing this bit of division, which allows a big number to blow things out, just looks for what is the middle number in the list of them after you've sorted them from high to low. So in this case, you would just kind of look for the 50th percentile value, counting down, right? Since we have an even number, there is no strictly middle number, but our median would be between 5 and 7 or 6. Now, that's the type of statistic that you might want to run in Python anytime you're studying your data, just to better understand it. That would be the smart thing to do as a data journalist. However, bummer, there is no built-in median function in Python. There isn't one that comes out of the box that's just the same as sum or len, that's there and available for you in your notebook without you having added anything or extended what the default Python tools can do. And that right there is one of the limitations that pandas and the more sophisticated data science tools are looking to fix. And so in our next chapter, we'll learn what pandas is, how to get it installed, and how it makes running advanced statistics like medians and even simple ones like averages easier by providing you with a tool belt for the many, many different tasks that we need to put together a data analysis. See you there.